Good afternoon, class. I'm Chase Callahan, and today we'll be discussing polar area. Now, how do we find polar area? Area can be found using the function a equals integral 1/2 radius squared d theta. Let's start with a quick sample problem. We're going to find the area under the curve r equals cosine theta on the interval theta equals 0 to theta equals pi over 2. First, we'll graph it. This is the graph of r equals cosine theta, and we're going to start from this point here to this point here and find the area of this. So, in order to do this, we're going to use our equation area equals 1/2 integral r squared d theta. So, let's start filling things in. We have our r equals cosine theta, so cosine theta squared. And our endpoints, pi over 2 and 0. Let's simplify this. This equals 1/2 pi over 2, 0, cosine squared theta d theta. Unfortunately, we can't integrate cosine squared theta, so we have to use a simple conversion. Luckily, it's given that cosine squared theta is equal to 1/2 1 plus cosine 2 theta. And sine squared theta is equal to 1/2 1 minus cosine 2 theta. So let's plug that in. Area equals 1/2 pi over 2 to 0 of 1/2 1 minus plus cosine 2 theta d theta. To simplify this, we have area equal to 1/2 times 1/2 pi over 2 to 0 of 1 d theta plus pi over 2 to 0 of cosine 2 theta d theta. So this equals 1/4 theta pi over 2 0 plus sine 1/2 sine 2 theta pi over 2 to 0. So, if we do some quick and simple math, that equals, so after a bit of quick and simple math that you can see right here, we find that the area under the curve is pi over 8. Now let's move to a slightly more complicated problem. We want to find the area between these two curves given by r equals sine theta for the blue curve and r equals cosine theta for the green curve. In order to do this, we have to actually split the area up into two parts, like this. Now to find this line, all we have to do is find where the two curves intersect. And in order to do that, we simply set the two equations equal to each other and find that they intersect when theta equals pi over 4. So, now that we have that, we want to add the area from here to here of the blue curve to the area from here to here of the green curve. This blue area is modeled by the function here, And the green area is modeled by this function, and to get the total area, we add them together. Now, since we know we can't integrate sine squared theta and cosine squared theta, we have these two conversions here. Now let's see if you can apply what you've learned to do an even harder problem. I want to find the area inside r equals 2 plus 2 sine theta and outside r equals 1. R equals 2 plus 2 sine theta is this curve, this green curve here, and r equals 1 is the blue curve here. I want you to find this area. In order to solve this problem, we first need to find where the two curves cross each other. In order to do that, we simply set the two equations equal to each other and find that they cross each other at negative pi over 6 and 5 pi over 6. So, now this equation here gives this purple area, but we want the blue area here. So in order to do that, we have to subtract the whole purple area minus this green area here. The green area is given by this equation. So when we plug in our conversions and solve everything out, we get that this blue area here is equal to 1/2 integral 5 pi over 6 to negative pi over 6, 4 plus 8 sine theta plus 4 sine squared theta minus 1 d theta. We simplify that and add in this conversion here to get that area equals 1/2 5 pi over 6 to negative pi over 6, 5 plus 8 sine theta minus 2 cosine 2 theta d theta. Then we can integrate. So we get this after integration, and after plugging it into a calculator and simplifying, you get that the area is equal to 14.782.